It's my pleasure to introduce Mr. Ravichandran D. Mr. Ravichandran is associated as Assistant General Manager for Product Management at Laser Cutting Systems. Coming with mechanical engineering background, Mr. Ravichandran is active in new product development with professional experience of more than 3 decades in machine tools, automation, and thermal cutting industry. Today, Mr. Ravichandran will give us a brief overview of laser cutting and automation. Please join me in welcoming Mr. Ravichandran.
Hello, everybody. Welcome to this webinar. And I thank the co-panelists and the organizers for giving me an opportunity to talk through the latest advancements in laser and automation allied with the laser cutting industry. Hopefully, I'll breeze through the thing because I have a lot more to show, but all pertaining to like what is needed for an automation, why an automation is needed, and what we have as an offering for those for the automation in laser cutting. Okay? So I don't want to explain more about laser cutting because laser cutting has become so common, like commodity says. As of now, there are a lot more advances which is happening in the laser cutting industry. So earlier we had only the CO2 lasers. Now fiber lasers have taken over the CO2 lasers, and the market has grown up like anything. Like it has been on a 30% jump year on year from 2018, amounting to nearly 2,200 machines in the last year in the whole of India. And this year we expect the same thing to reach up to 2,600 to 2,700 machines in 2023 in India. So it's like machines are being dumped in India means the technology is improving. So what are all the latest advancements in latest advancements in laser cutting is high power availability. So in India, we have started using earlier, we used to have only up to 3 kilo. Now we have started using 6, then 12, and now 20. In India, people have started using up to 20 kilowatt. And in the globe, across the globe, now even 100 kilowatt laser is available. Like I think a couple of weeks back, the Rakers has launched their 100 kilowatt laser. So it's like, it's mind-boggling to understand what level of technology is getting upgraded. So what's the benefit of this high power lasers? Like you get more speed in cutting, high quality, plate thickness. You can go up to high thickness of plate. So earlier, like we were always telling you can cut only up to 25 mm of mild steel, but now you can cut up to 40 mm, 50 mm, stainless steel up to 50 mm you can cut. And people are showing samples that they have cut up to 100 mm, though the quality is not that good. I was just telling you about the high speed availability and how it's changed the cutting process. So when you take a mild steel, for example, a mild steel 10 mm, which was the speed of cutting is around 1.5 meters per minute of the 3 kilowatt, which we're experiencing nearly maybe 4 years back. But now we have the option to go up to 12 kilowatt or 15 kilowatt. So just for an example, if you take a 12 kilowatt, you jump up by 47% per 6 kilowatt. And when you have a 12 kilowatt cutting a 10 mm plate, you jump up to 173% of the 6 kilowatt speed. So the cutting is done at a high speed, so more productivity, and the quality is better. And another thing is plate thickness can be higher. And then this one advancement is higher powers. And then air cutting, they use air as cutting media. So they can cut up to 10 mm, wherein they can increase the speed nearly 3 times or 4 times, like how they are cutting a stainless steel. And so the production is high. And enriched nitrogen and mixed gas. This is a new technology where oxygen is mixed with nitrogen at a percentage of 1 to 3%, depending on the thickness of plate. And with that, if we cut, the speed is higher, the quality is better, and the cost is very low. So like cutting with nitrogen has got more cost involved, but when you cut with mixed gas with a combination of oxygen with nitrogen, then your cutting cost is very, very low. So it's like the advances of in laser, fiber laser, brings out high productivity, high quality, and low cost of production. Okay. So this is the advancements in laser cutting technology. And just to give you a oversight of what products we at Mesa offer for the laser cutting process is like we have got a 3 standard format machines, starting with fiber light, which for the low power up to 3 kilowatt. Then we have got fiber blade 5 for up to 12 kilowatt. Then up to 20 kilowatt, we have got the fiber blade 6. So all these machines are with a state-of-art Mesa controller with all embedded laser features. And these are the normal machines which you see in the market. We too have the gantry machines, like in which lasers can be used, and like the widths can vary up to 5-meter cutting width for a length of around 24 meters. So it's like you can use 12-meter plates to cut also. So, and the other thing is, in these machines we can have laser beveling. I think no other supplier in India supplies a laser beveling, because whenever a plate is cut, generally it is beveled, so that it's a welding requirement for welding operation. So normally what the people do is they cut the plate and then they do a secondary operation. But with our machines, you can do the beveling operation on the machine in the one. So these are the advancements in laser cutting technology. Okay? So this is to just tell you about the bevel cutting option in laser. We have named it Bevel U because of the arrangement of the equipment, where you can cut up to 45 degrees, plus or minus 45 degrees. Okay, these are some of the pictures of the bevel cut samples. Then coming to automation, like I've told you, like laser has evolved over a period of time as a major cutting process, eating into the optical and plasma cutting market. It's literally taken over the plasma cutting market totally, and it's available like a commodity. So all these things can be improved. The productivity can be much improved by automation on these machines. So if you really see, we have now got high productive machines, and the manufacturing process in many industries across the industry is going towards lean. Lean means like it's not like huge batch production is not a norm now. It's on small quantities, much needed quantities only. So what happens is frequent change in setup, frequent change in the loading material type. So all these things bring about a lot of manual intervention other than the cutting. When a lot of manual interventions are there, you will have a lot of idle time with the machine waiting for material. So automation we have to address the idle time, limit it to the least possible extent. Then the next one is whatever you have done, your process to be optimized. Not just the machine, the material flow and the requirement, material stocking, and the parts to be supplied to the next machines. All this has to be optimized. So you should need a proper scheduling. So you should have, if it's manually done, you'll have a lot of issues like errors and rejections, waste. So if you want to do that, if you have a process automation in the process optimization, that will be much useful. So, and lead time. Now, most important thing is not in the lean manufacturing, it's the lead time. So when you get an order, what is the least possible time you can take to deliver the goods? So I'm talking in any industry. So as well as in the cutting industry also. So all these things can be addressed by having an automation assisting the laser cutting machines. So this automation can be split into two varieties, where the automation can be on the material handling, either on the storage or transfer of the material from the storage system to the machine, or the machine feeding area, or after cutting, a big plate is cutting the small parts. or either by sorting it, picking the necessary parts, putting it in a designated bins or pallets. So all if these all doesn't need any, I would say, intelligence. It means just organized workflow. If that is done by a material handling system, that will assist the cutting industry in a big way. And the next thing is digitizing the process. And that is like optimized production process and then monitoring the cutting process in real time. So it's not just planning. It is like when the actual work is being done, if you are monitoring it real time and remotely, I would say remotely, that's what I think Neeraj would have been pointing out in the 4.0. Monitoring in real time also helps in a great way to enhancing production. And then once you're done with the production, like you have to have analyze the data so that your future process can be still streamlined. So two areas where we can automate is on the material handling and the process digitization. So first, let me talk about material handling, and then second, I will talk about the process digitization. So these are the benefits. I'll just breeze through because I will explain it in detail at the end. So material handling, I'll just run a video so that you know what we are talking about. So you're getting the raw material. You can store it on a vertical storage, which can save space. And when you're doing all this, you're planning where to put the material. So there's a lot amount of planning on material movement also. So if planning is there, then you are going to optimize. So now I'm taking out a pallet on which the plate is there, which is to be fed to the laser cutting machine. So it is brought to the other side of the tower, storage tower, and then it's stacked in place, which we call it the transfer station. Now coming back to the machine. So a cut pass plate has come out, and we have got an automated foam structure which lifts the cutting material, cut pass, not the cutting material, cut pass, and unloads it to the place. Here we have shown a pallet. It can be a pallet, it can be a conveyor, it can be a trolley, whatever it is. So, which I will explain to you in the next slides. It drops the cut parts and then picks up the fresh sheet and loads it on the machine. This is called a typical example of a material handling and feeding system. So we call it a loading and unloading with a storage tower. So this is not like this is one type of a system, and this is highly configurable based on the customer's location, customer's requirement, and how their machines are placed. So it depends on the number of machines. It's one machine. So a fresh plate is loaded. And since this is a shuttle type machine, you have another plate already inside. So this is a whole gamut of the productive type of material handling system. So in the center, you have the cutting machines. So normally what they do is by forklift or overhead crane, people load the material onto the machine. Then from that, they take the cut parts and take it out on their platform. So if this is unmanned, how it happened? We have a vacuum lifter and a foam unloader. So this is used to pick the plate and load it on the machine, and this is used to pick the cut parts and unload it on the station. So in between, we can have a storage tower where these plates are stored and taken out when we need the plates to be loaded out to the machine. Or else you can have a cart like two cars going back forth. So one is used for loading and the other one is used for putting the first raw material. Or a station just like that. So all these things I will explain, and this can be two different elements, or it can be a single unit like what I showed in the previous video. I have different videos, but I don't want to take much of your time. And these are like, you have separate loader and separate unloading station. This is the tower. This was an example. And this is the system which I showed in the video. in different configurations. You need not have this tower, you can have just a pallet. This can load and unload over here. So you can have the loading and unloading separately. You can have a cart so that you don't enter the place where the loading is happening. So a lot of configurations. So you have the compact version also, wherein a single machine, on top of it you have a loading unloading system, very compact and low cost also. It's like this. Just a video to show you this. So these are the fresh plates. Now this comes and picks the plate, and the cut parts are picked by the comb thing simultaneously. So I'll just breeze through. So these are type of different types. So we don't have much time. So we can have a vertical storage also. So this like 4 machines running with one single loading unloading station, like what I have shown below. So automation helps a lot many ways. And smart trays, like after you cut, you can pick your plates and store it on. Like after it's cut, you can pick by the pickers. It can be single, multiple. So you can pick and put it over here so that a man need not interact with the machine at all, physically. So it's like after the plate is cut, it picks the cut plate and puts over here. So next stage of improvement in the laser cutting industry will be automation of the laser machines. So I just breezed through. Then process digitization. I was telling one type of automation is on the machines, on the physical material loading and unloading or handling. Now it's in the process. So why this process automation? So people normal question is what the customer asks is how to transfer the data from the ERP system without manually entering into the production system. How to do it automatically. That's one thing. And what is the overview of production? How do I know what is being cut, what is being processed? So all these things, how can I schedule it automatically? So you have 2 or 3 types of machines, and how do you schedule it so that each machine doesn't wait for material? So there's a smooth flow. So it's like you have the data coming from the ERP, then you have a scheduling for the machines. Then from the machines, you take up the data of what is being produced and give it back to the scheduler and the ERP system so that automatically the stock of the cut parts or the process parts are added. So there's no human intervention. It's done automatically. So we have an ERP connect, a job scheduler, and a PDC, or process data capture. We call it as a PDC in our offering. So it's an OmniFab we call, and we got a machine insight also, which gives a live machine data, whether it's working, or whether it's idle, or how much idle hours it has kept, what errors have been popped up. So these are the inputs for the machine to get enabled to Industry 4.0. And this machine insight gives the data not to the operator alone. If it's connected to the internet, then the whole management can look at it in their mobile phone or their computer also. So they know what's happening right down in the shop. So we have for nesting and digital automation, it's like this. Now the ERP, then automatically you can give codes, then job management and material flow can be managed, and PDC is getting the information from the machine, and machine insight is for real-time information on the machine, utilization of the machine, and what are the idle time and the errors because of what types of errors have happened, or if the machine is idle, why it has been idle. So all those data is available and you can analyze that. All this will enable us to reduce the bottleneck. It will show the bottleneck because it shows the bottleneck in advance, and on time you can ensure that your on-time delivery is really happening, and high transparency is there. So if there's a manual collection of data, there's literally very less transparency. Now anybody who has the system can look into how the machine is performing. So these are the two types of automation. One is the process automation and the material flow automation. So what are the benefits of that? So increased productivity. Your machine can run 24 by 7. So if it's running 24 by 7 non-stop, it increases productivity. And then low operating cost, because the machines are efficient enough, because it's replicating the action over and over again much better than a human. And so you have less labor cost and few errors, and then material waste was also reduced. So an increased product quality, because your machine, when it is loaded by a material handling system, it's handling it accurately. The material is not tampered upon, and there is consistency. So in the handling system or the finish system, so your quality is also ensured. Then it increases worker safety, because on the physical front, a man doesn't approach the area where the machines are operating. So it's like it's very safe for the human. And then improved work atmosphere, like the machine takes over the tedious work, whereas the human takes over the creative jobs in the planning and execution is done by the machine. And then better use of floor space, like when you store vertically, you get no space for other machines. Okay. So easy integration nowadays, all the material systems and the digitization systems have become more flexible and more easily adaptable with many number of systems. So which on the existing system also that can be incorporated, which helps automation, availability of automation on the existing assets also. And then since storage can be done vertically, and then effectively loading can be done, and reduction in waste is there. So it means that energy usage is optimized, and all this translates to a lower carbon footprint. So it's like automation in any industry gives you all these benefits. It's a generic type of benefit. And especially in the upcoming market of laser, which is growing year on year by 30%, these are profoundly seen. Okay. And this is the end of my presentation.
Thank you, Mr. Ravichandran, for sharing your insights on laser cutting and automation.